Good day, y'all. My name is Haji Ogeneogo. I'm representing on prediction using decision tree algorithm. This project is part of the requirements for the Sparks Foundation internship program on data science and business analytics. This is task number 6, and for this task, we have to create a decision tree classifier and to visualize it graphically. The data used for this task is the iris dataset. Going back to the collab notebook, the first thing I did was to import the libraries I needed, and especially the decision tree classifier, which will be used for building our model. The graph viz was also imported for visualization. PyDot+ is a library used for as an interface between Python and Dot language. GraphViz is written in Dot, so PyDot+ enables Python to interact to pass the GraphViz. I uploaded the data to my drive and I had to mount it into this notebook. After that, I read the data into the project. And this is the resulting data frame. You have the ID, the sepal length, sepal width, petal width, and the species. And checking to know the unique species we have in the data using .unique, we realize we have the setosa, the versicolor, and the virginica. Now, to build our model, we need to separate our data frame into the independent variables and the target variable. Now, the independent variables here are the sepal length, the sepal width, petal length, and the petal width, while species is the target variable. So we assign the independent variables to x using the drop method. We drop the species and the ID columns because the ID column is not really needed for building our model. And viewing the resulting data frame, we have this data of sepal length, sepal width, petal length, and the petal width. Now, like I said, the species is our target, so we assign that to y, which is our target variable, and also this is the resulting data frame. So we build our model, and we'll fit our data to our model using the x and y dot fit method for x and y. After fitting our data to the model, then we visualize it using the graphics and the PyDot+ libraries. And this is the resulting decision tree. Now, in this decision tree, petal width is the question being asked. The the question being asked. And if true, this is what is the result. And if it is false, this is the result. Gini is a coefficient that shows how equal um, the classification is. A Gini value of 0 is a perfectly equal data with less entropy, while a Gini value of 1 is perfectly unequal, perfectly unequal, not equal. Now, for there are 150 samples, and after the first question has been asked, if it was a versicolor, true, 50 samples came out true, and the class was a versicolor. And if you can see the Gini value here of 0, 100 samples came out as false, and the class was assumed to be Setosa for now. And the Gini value, if you notice, had reduced to zero point 0.5. Another question was asked if the petal width is now less than 1.75, less than or equal to 1.75, and 54 samples came out true, which were also kept as a Setosa class, and the Gini value had reduced to 0.168, while 46 samples came out false with a Gini of 0.04. And that is how the questions will keep on being asked and answered if that's true or false until a perfect Gini value of 0 has been met. At the end of this decision tree, the species of the flower would have been classified perfectly, and the number of samples in each class of flower will be known from the sample values, from taking the sum of the sample values. This is the end of my presentation. Please drop a comment. Thank you.